Hey guys, let's discuss new problem from dynamic programming, which is called coin change 1. Okay, so here you would be given a few coins, okay, and one target sum, and you need to form a change of means coin changes something like you will have a minimum coin. So for example, if someone is asking you the sum of 5, okay, $5 for example, and you have a coins of let's say denomination 1 comma 2 comma 3, okay, so what is the minimum number of coins you will give him? You will give him one $3 coin and second one is $2 coin, correct? So now this is what we need to find the minimum coins, okay, and this is the part of unbounded knapsack concept, okay, in that category. So you can take same coin multiple times, okay. Now the recurrence relation is similar to knapsack or rod cutting or everything, because all these fall into one category, okay, one type of pattern, and we are covering here all the pattern from dynamic programming. So this is the type of unbounded knapsack pattern. Now here let's create table for it, okay. Let's see quickly how you can solve it. So let's say you have a coin 1 2 3, okay, and the target sum is 5, so I will take 0 as well, okay. 0 1 2 3 4 5. Now tell me one thing, if someone will ask you to give number of coins for the zero sum, right, so what you will give him? 0 coins, number of ones will be 0 0 0, okay. Now someone will ask you that give me 1 rupees or $1 coin change, okay, and you have only one denomination 1, okay. Multiple coins you can have, so how many coins will you give him? 1 only, right? And for 2 you will give two $1 coin to him, right, because you can take multiple coins. Similarly for 3 4 and 5, right? Now you have a denomination of 2 and 1, okay, and someone will ask you for the $1 coin change, so what you will give him? See, you cannot give him $2, okay, but you can give him $1. So whatever is coming for the previous result you will copy as it is, because this sum is lesser than this 2, right? So 1 will come here. Now when you have a when someone will ask you $2 coin, okay, so what you will do, and you have if you include this 2, right, if you include this 2, so 2 minus 2 0. Now you go in the same row and check what is the value for 0 column. So in the same row for 0 the value is 0, okay. So 1 coin, so you will give from here, okay, and then 0 from here, so total will be 1, so 1 will come here. Now for 3 so 3 minus 2, 1 is remaining. For 1, what is the value? 1. So 1 for this $2 coin and 1 for this one, so 2 will come here, okay. And then for 4, what will be the answer? 4 minus 2, okay. 1 you will take $2 coin, and remaining 2. For 2, what is the answer? 1, so 2 will come here, okay. Now for 5, what will be the answer? 5 minus 2, 3 remaining, okay. So 1 for this 2 and 3 remaining. For 3, the answer is 2, right? So 2 plus 3, so you will give here 3. Now you have a 3, okay. 3 is correct here. If you wanted to give someone a change of $5, what you will give? And you have a $1 and $2, so minimum is two $2 coin and one $1 coin, okay. So total 2 plus 1 3 coins you will give him, right? Now check for 3. So because 1 is lesser than 3, you will take value as it is, okay, whatever the previous calculated value for this 2 and 1, and then here 3 minus 3 0, so 1, okay. And then if you wanted to give someone $4 coin, and you have denominations 1 2 and 3, and if you take this 3, okay, so what is remaining? 4 minus 3, 1 is remaining. And what is the answer for 1? For this row it is 1, so 1 for $3 and 1 for this, so 2 will come here, okay. Now for 5, what will be the answer? 5 minus 3 2, and for 2 1 is the answer, so 1 plus 1 2, so the final answer will be 2, okay. And if you wanted to see how the coins will contribute here, so see, this 2 came from here, right, from here, so 3 will come into your answer. Then how this 2 came? This 2 came from here, right? So this 2 will also be in the answer. So 1 $3 coin and 1 $2 coin, so total 5. So that will be your answer. And if you wanted to see the recurrence relations, okay, so we know that we are you can take element multiple times, you can take one coin multiple times. So here you will not check j minus 1, here you will check j, okay. You will not check previous. You see, if I have taken this 3, and I can take because in the previous problem either we can include it or exclude it, because one item we were able to take once only, okay, in bounded knapsack, not in unbounded. So in that case, what we were doing, we were taking this variable and then was going to one step up, because now again you cannot take this variable, right, this value, but here you can take this value. That's why we are on the same row, okay. So here whatever is minimum from the previous calculated value, so for example for this, either this one is minimum, either you take this, okay, otherwise you take 1 plus, because 1 by 1 because you are including this, okay, and then you are subtracting this 3 from your sum. So 1 2 3, so this value, coin I minus 1, okay, j minus I minus 1. So this is the recurrence relationship, and the DP problem is exactly ditto. Okay, you will create one, you would be given coin array and total sum, and then you will find the coin length, okay, coin array length, and then you will create one 2D DP array and with size n plus 1 and sum plus 1 for 0, okay, and then you will iterate it, and you will put 0 comma j to integer max minus 1, either you put infinite or 0, that is fine. Now here we have taken 0. Now here yeah, so we have initialized it with 0. Actually they have taken 0 here as well. Like if they take 0 here, then what will be the answer? Whatever you have here, that one, okay. Then they will take 2 for loops, not actually here, whatever is here. So 0 infinite will come, right? So it means that you need to give someone $1 change, and you have $0 denomination. So how many zeros you will give? I will give infinite 0. Then only $1 sum will come somewhere if exists the value, right? That's why they have taken max value minus 1. So now you will iterate this 2D DP array, and you will use your recurrence relationships, okay, if your coin I minus 1 is lesser than equal to j. In which condition? So see here 3 was here, 3 is here, so for this area, okay, before that you just take whatever is as it is, because it is smaller, right? So that is what we are doing here, and at the end you just return DP n comma sum. That's it. So that was the problem. Thank you.